Module 8, Lesson 4 covers the area of regular polygons. The textbook is claiming that this is going to be a 2-day lesson, but considering there's only 8 resources to use with it, I kind of have my doubts about that. But let's get into it and see what they have to say. When automobiles were new in the early 1900s, there were no driver's licenses, speed limits, road signs, or traffic lights. The Mississippi Valley Association created a set of guidelines to determine the shape of road signs. The more sides a sign had, the greater its importance. The railroad crossing sign was a circular sign with infinitely many sides. The stop sign was octagonal, and the triangular yield sign helps drivers to determine how to merge onto a highway. A school zone sign shows its shape as being a pentagon. You know, I never knew that. The number of sides on it indicate how important the sign is. That's pretty cool. Using what you know about how to find the area of some figures, how might you decompose a pentagon to find its area? Well, I'm thinking that we could chop it up into a triangle and a trapezoid, and that would get us the answer we need. From here, let's go ahead and explore some regular polygons. To find the area of a regular polygon, which is defined as a polygon in which all sides and all angles are going to be congruent, you can decompose the figure into triangles, parallelograms, and trapezoids. Find the area of each smaller figure and then add the total to get the total area. We're going to got an animation here to go over this with us to help us understand what to do.
A regular polygon is a polygon with all congruent sides and all congruent angles. This hexagon is a regular polygon. Each side has a length of 2 centimeters. To find the area of a regular polygon, first decompose the figure into triangles, parallelograms, and trapezoids. The hexagon can be decomposed into 2 congruent trapezoids. Next, find the area of the polygons that make up the hexagon. Use the formula to find the area of the trapezoids. The area of the trapezoid is 5 19/100 square centimeters. The 2 trapezoids are congruent, so the areas are the same. Finally, you can find the hexagon's area by adding the area of the polygons that make up the hexagon. Because the trapezoids are congruent, the areas are equal. So, the area of the hexagon is 10 38/100 square centimeters.
Alright, now I missed something here. I want to see how they got that height right there. So let me see. I'm going to turn up my volume here and watch that part again.
Decomposed into 2 congruent trapezoids. Next, find the area.
Somehow they shook some voodoo sticks here and came up with that number, and hopefully with the problems we have coming up, they're going to provide it for us, because that is a whole big bucket of worms of information we don't know. How they got the 1.73 and the 4 here. Hopefully they're going to provide that to us in the problems we're going to work. A step sign is shaped like a regular octagon. Each side of the stop sign is 15 inches, and it measures 36 inches between the parallel sides. So we have 36 inches this way, 36 that way, and all that happy stuff. Find the area of the octagon. Well, to do that, we're going to need to decompose some sides here. So first thing they want us to do is move through some slides and see how they're going to cut it up. And what they chose to do is cut it right across that way. And when they did, well, what do I see? I see a 5-sided figure there. I don't really see anything we've learned how to use. So let's see what else we can do. We can take and cut it up a whole bunch of other ways. And when we do that, what we have there is a whole bunch of triangles, 8 of them in fact, and we could take those 8 triangles, and you can see that you got, still 8 triangles, they just have them shaded different colors now. Well, it decomposes therefore into 8 congruent triangles. That's going to be a good start. From there, how should we proceed? Well, let's see what the next suggestion is here. find the area of each triangle. Now a triangle's area is equal to base times height. And let's just take a minute here and go back and talk about where they're coming up with these numbers here, 15 and 18. All right, so I'm going to go back to my previous slide here, show some triangles here, and get a screenshot of it so that we got something to work with here. Well, I totally messed up that screenshot. Let's try another one. And when we do this, paste it over here. Alright, almost there, folks. There we go. So when you do this, think about what you know about these triangles, about the stop sign. First thing we know is that each one of these sides are 18 inches, right? Was it 18 or is it 15? Let me go back and check the original problem here. So we got show the problem. It says that each side is 15 inches, so yep. And then from there, we can take and say that the width of that stop sign from here to here, that was going to be 32. I'm sorry, I think that actually said 15 inches, did it? Yeah, it's 15, not 18. So that means that the distance, if you were taking cut right down the middle of that, from here to here, half of 38, or 36, that's going to become our 18. Which you can see you've got right here. And that's how they did each of the triangles. They had a base of 15 and a height of 18 going to the center there. From there, we're going to take and jump back over to where they were showing their work. 1/2 of 15 times 18. Well, I'm going to take and say 1/2 of 18 is 9. 9 times 15 is going to be 90 plus 45 is going to be 135. So the area of each one of those individual triangles is going to be 135 units. But we're not done yet. The problem didn't want to know how much 1/8 of that stop sign was. It wanted to know the area of the entire stop sign. So to find that out, we're going to have to take and see here, because the triangles are congruent, multiply the number of triangles, which is 8, times by the area of each triangle. That means that from here we're going to say 8 times each triangle was 135. I don't know why I keep getting a decimal there. There you go. 135, which is going to give me 800 plus 240 is going to be 1040, plus another 40 is going to be 1080. Yes, I actually just did that in my head. And so the area of the entire stop sign is going to be 1080 inches squared. Once again, it's going to be your turn to work a problem where we're looking at a pentagon that is one of the little tiles used to make up a soccer ball. They also went ahead and gave you a pretty map of that pentagon showing you that each piece can be divided into 5 triangles. Each of those 5 triangles are going to have a base of 1.8 inches and a height of 1.2 inches. You go ahead and work through the problem and to find out the area of each side of the pentagon, or each pentagon, and they said to round your answer to the nearest hundredth if necessary. Alright, so we've got our picture here. We've got triangles. So the formula for area of a triangle is going to be base times height divided by 2, which is going to mean I'm going to have a base of 1.8 inches times a height of 1.24 inches, all divided by 2. And that means that my area is going to end up being, well, I'm going to take and simplify here, I think. I'm going to say 2 goes into 2 once, 2 goes into 1.8, 0.9 times. And from there, I'm just going to do some real quick grunt work. 1.24 times 0.9, 9 times 4. That's going to give me 36. 9 times 2 is 18, plus 3 is 21. And then we're going to get an 11 there, and we're going to bounce it 3 spaces, which means rounded to the nearest hundredths place, we're going to be looking at an area of 1.12 inches squared, if I did my math right. 1.12, check. Uh-oh, not a happy sound. And you know why it's not a happy sound? Because I only found the area of one of the triangles. I have to take that 1.116 and multiply it times the 5 triangles, 1.116 times my 5 triangles. And when I do that, I'm going to end up getting, let's see, we got a 30. That's going to be a 5, 6, 7, 8, a 5, and a 5. And then we'll end up getting, boom, I have messed something up here, I think, maybe. I don't know. Let's find out. Rounded to the nearest 100, 5 and 58 hundredths. Let's see how it works. 5.58. Hey, I didn't mess it up. Excellent. That's showing your work, folks. And that is also all there is to this lesson. Told you it was going to be quick and simple. Go ahead and get started on your homework. Make sure you give me some good drawings to go with your algebraic supporting work. I need formulas. I need lots of big kid math on these. I look forward to seeing what you get done.